Gaining access to a system is only one part of an ethical hacker's job, but what comes after is a whole different game as they attempt to maintain it. Persistence is what allows a foothold to survive system reboots, user logouts, and other interruptions. In this video, we'll explore 3 entirely different persistence techniques that attackers commonly rely on after gaining access to a new system. By the end of this video, you will be confident with maintaining access on Windows systems. So sit back, get comfortable, and let's dive in. Alright, for this video we are working in an assumed breach scenario, since persistence falls under the post-exploitation or maintaining access phase of the ethical hacking methodology. In other words, we are starting from the point where access has already been gained. And here is our shell to a Windows 11 target. If you're not familiar with reverse shells, I'd suggest checking out this video. But anyways, our first technique for today is going to be the Windows startup folder. This is a very simple concept. It's just a folder that executes files in it on startup. We can navigate to this folder using the following path. Any files in this folder will run on Windows startup for the specific user. Okay, so our plan should be very simple here. We just drop a reverse shell in this location. I have one prepared already, which is right here. This one is also currently undetected by Defender, because our Windows target box automatically re-enables Windows Defender on a restart, and having an undetected reverse shell is the best for this demo. If you're interested to know how I set this up, I would suggest watching my AV evasion video. I'll set up a Python HTTP server. Let's check our attacker IP. And I will use the invoke web request cmdlet to pull the binary from the attacker web server. Okay, our file is now in the startup folder with this maybe kinda convincing name. So let's test this out. I will exit this reverse shell and I will switch over to the victim attacker view. Okay, here we are. I'm going to start listening on the attacker machine. On port 443, that is the port that the reverse shell is configured to connect back on. Now let's restart the victim machine and see what happens. Okay, here we are. As you can see, as the machine is booting up, even if we don't log in with our password, there we go, the reverse shell just pops up and the attacker is logged onto the machine before the victim himself. If the user logs on, as you can see, there is no trace of something malicious going on. The next technique we're going to explore are Registry Run Keys. These are registry keys to make a program run when a user logs on. As you can see, we have 2 options. We have run and run once, where run makes the program run every time the user logs on, while run once makes the program run one time and then the key is deleted. And here are the locations of the run keys in the registry. We'll use the current user one to run the binary as the current user, and we will use the run key so that it runs every time the user logs on. Alright, here we are back in the assumed compromise scenario. I have removed our malicious file from the startup folder. So let's set up the run key and see how it works. The first step is again to get the reverse shell on the victim file system. I have uploaded it in program data. Let's hide it in another folder for good measure. By the way, as you can see, it is a bit hard to work with a non-interactive Windows shell. If you're interested in getting fully interactive Windows shells, you might want to check out this video. Okay, so the second step here is to set the key. We can do this with the reg command. There we go. And the syntax is as follows. As you can see, we are adding a key in the location that we saw from the Microsoft documentation, and here we need to specify the name of the key. So let's do Windows Update Service. And here we need the path of the binary that we want to execute. So let's go grab that. Okay, that looks good. So let's copy this whole thing. And let's execute it here. We get a message that the operation completed successfully. We can now use reg query to query the run key and see if our value appears there. And as you can see, there it is. Now let's test it. I will exit the reverse shell. I will run a netcat listener on port 443 and I will restart our victim machine. And there we go. As you can see, again, before even the user has logged in, the attacker can already control the computer. Let's log in. And nothing suspicious is going on over here at all. The last technique I have for you guys is persistence via scheduled tasks. Let's first delete our run key value. We'll do this with reg delete. The syntax looks like this, where here we have the name of the value. Let's run it and let's confirm that it was deleted. It's no longer there. Okay, for scheduled tasks, we again need the binary that we want to execute on the file system of the victim machine. We already have it in program data from our previous technique, so I'll just use it again. For creating the scheduled task, we will use the sch tasks utility. There we go. The syntax is gonna be the following. We'll have the task name here, so let's do Windows Update Service. Here we have the path of the binary, so let's specify it. And here we can specify the interval between execution of the tasks, or when the tasks trigger. With the syntax I have here, the scheduled task is going to run every minute. But this could also be set to every hour, every day, or on startup as well. But for the demo right now, let's do 1 minute. So I'll copy this, exit out of here, and let's paste it here. And we can see a success message. Let's check all scheduled tasks to verify it was created. And as you can see, we have it right here. Okay, what I'll do now is I will exit this shell and I will run the listener again. And as you can see, after waiting for a couple of moments, we got our reverse shell back. As you saw, we didn't really do any witchcraft in this video. We simply used some features of Windows to our advantage, and that is very often the case in ethical hacking. We abuse a feature to achieve perhaps unexpected or expected but unpreventable functionality. In any case, that's gonna be it for this video. I really hope you enjoyed it, and see you next time.